The next to doodle, we're saving this page as a warm-up problem, but we are looking at this one next. Sophia asked students at her school if they have their own cell phone. Unfortunately, her sister spills pasta sauce in conveniently small circles, making a puzzle for us. What numbers are under each of these red dots? Notice that the total, so these two numbers have to add up to 18. These two numbers have to add up to that spot, and so on. And there's also totals here. So these three numbers will add up to 27, and so on. I'm going to pause it while we work on this. Our first one was 5. You could think about this as what number plus 8 plus 14 makes 27. Or you could go down, what number plus 13 makes 18. Okay, we finished our
This meeting is being recorded.
So 14 plus 2 is 16. We did 13 plus something plus 2 is 21 to get the 6, and then 8 plus 6 is 14, and we could double check that these really made 48, and everything looks good. So part 2, what's the fraction of students in each grade that have their own cell phone? So for grade 6, we want part over whole. So tell me the two numbers and I'll write them as a fraction.
So is it 527 or no?
So just the 6th graders, 5 of them had a phone. How many are total?
Oh, 18.
18. For the 7th graders, how many had a phone?
814.
8 out of 14. And for the 8th graders,
1416.
yeah. Everyone happy with those answers?
Yes.
We're not quite sure why they wanted this written as a fraction, but we could do it. A great thing about unit fractions is it's almost the same picture when we are adding. Remember, adding is combining things. I have 4 things and 2 things, and I link them all together, and there's 6. Or when we are multiplying, and remember, multiplying is selecting a fraction of. I have 6 things, and I want half of the 6, so that's 3 of them I get. So I will narrate this for you. You don't have to do anything. I'm going to start with a third. Everyone happy that my green is a third? And I'm also going to shade in a half. So here I go. I want to do the top piece, right? So I'm going to start shading it in. Uh-oh, bump. I want to shade in all the way across the top, but that piece has already been shaded. I don't want to double count it. So I'm just sort of going to change direction and shade in a different way. Everyone okay with that?
Yes.
So we had our 1/3. And we had our 1/2. And life was pretty good with combining them, except that when they would double count, we had to move a blue square. Now I'm going to talk about starting with a third. So here I am. And now I want to shade in a half, but not half of the whole rectangle, just half of the third. So I'm going to say, here's a half. Where is a half of that third? it's this one. That's the top half of my third. Are you with me there?
Yes.
So it's almost the same picture. When we're adding, we have to avoid double counting the overlap. I don't really care what the answer is, but if I wanted to write the answer, how many sixths did I wind up shading? 5 of the 6. When I'm multiplying, the overlap was the answer. What is half of the third? It's that top half of the third. It's just 1 out of 6. Later on in life, when you are talking about adding fractions and multiplying fractions, someone will teach you that you need to have common denominators for adding, but you don't need common denominators for multiplying. And this slide shows you why. When I was doing the process of adding, of shading in this top, I had to kind of bump and figure out what to do during that process. In other words, sixths were involved before I finished adding. Whereas on the other side, I could shade in the top half of the green and put a smiley face on it before I had to think, how big was that? It is a sixth, but the sixths weren't really involved until I'm looking at the name of my answer. So that's a big difference, that when you're adding, the piece size that you wind up with, the sixths, is part of the adding process to avoid double counting. Whereas when you're multiplying, you don't care that it's sixths until you're looking at the answer. So file that away in the way back of your brain somewhere for when you need it. How about subtraction? You do this one. After a party, there's half of a cake left over. And then late at night, you sneak into the kitchen, and what you eat is a third of the original cake size. How much remains? You shade it or tell me what to draw.
So there should be 2 squares left.
I don't want to jump to the answer, so tell me how to make the pictures.
Oh, okay. So first shade in the first 3 squares.
Okay, whoops, I'm gonna use this because it's easier for me. So here is the half the cake that's left over. Couldn't have been that good a party.
And then shade in one of the bottom of the squares.
One of the bottom of the squares, like that.
Yes.
Okay. It looks to me like you added more cake, like someone snuck and put their piece back. I think the gray shading is making this a little hard. What if I shaded my half of a cake not across the top, but just sort of that L? So there's the half that's left. What's a third of the cake to take away?
So are you cutting one of the squares into thirds?
I
And
want
then,
to cut the whole original cake into thirds, not just the leftover amount. So we've seen that a lot, thirds. How do I shade a third of the original cake?
so do you just shade one of the squares that's already shaded?
That would be a sixth of the original cake.
I don't know. I guess I'm just kind of confused.
What does a third of the whole rectangle look like?
So two of them?
Two of them, yeah. I'm going to go, if it helps you see, then, oops. It's like 1, 2, 3. So I want to not do a sixth, but a third of the original. So the gray is what I had left over after the party. The one that I have cross-hatched is the one that I eat at midnight. How much is still there? That's just 1 out of the 6 pieces. Does it make sense now that you see it all?
Yes.
This is a very strange problem because people wouldn't normally say, how much of the original cake did you eat? They would say, how much of the leftovers did you eat?
Yeah, I
But
guess
this
that's
is,
kind of how I was a little bit like trying to, I guess that's how I was understanding it.
yeah, but this is the kind of awkwardness that the GED might like to do for you, which is why I put this one on. Another common situation with unit fractions is discussing time. Last weekend, Andrew went on an enjoyable hike for 2 1/3 hours. This weekend, he was only able to hike 1.5 hours. How much longer did he hike the first weekend when he had more time? How would we figure that out?
Would it be 2 1/3 minus 1.5
It
hours?
is, but we're not quite sure how to do that. That's a pretty tricky amount of fraction math because we have these mixed numbers and the thirds and the halves don't match. Let's use the fact that it's a clock to help us.
So we would do like a 12, like 2 12s.
2 12s. How many minutes are each hour?
60.
60. So 2 1/3 hours is 60 plus a 60 plus what's a third of an hour?
20.
20. So going a third of the way around here. So that's my first number. And I'm going to take away 1 hour, that's 60, and then half.
$30. Half minutes.
Yeah, half an hour is 30 minutes. So 60 and 60 and 20, that's 140. Nothing wrong with using a calculator if you need to. 60 and 30 is 90. So 140 minus 90, 14 minus 9, so 50 minutes. This is another kind of thing that the GED would love to toss at you. They're giving you a problem in a annoyingly unhelpful type of measurement. Hours is not the right way to think about this. But when you switch to minutes, then it works out much easier. And we're done. Sure why that one got the blank one. Okay. So it is 7:52. Thank you for being with me. And any other questions before we're done? And I'll see you Thursday.